Lensing Tate, the Executive Director of the UWM Alumni Association. Thanks for joining us this morning as we learn about NASA's SOFIA, the world's largest moving observatory. It's my pleasure to introduce Dr. Jean Creighton. Dr. Creighton is an astronomer and since 2007 has been the director of the Manfred Olson Planetarium at UWM. She grew up in Athens, Greece, and earned a doctorate degree in astrophysics from the University of Waterloo in Canada. In 2014, Dr. Creighton was selected by NASA to be an Airborne Astronomy Ambassador, where she spent 20 hours in the stratosphere on SOFIA, which stands for the Stratospheric Observatory for Infrared Astronomy. SOFIA allows astronomers to study the solar system and beyond in ways not possible with ground-based telescopes. Today, Dr. Creighton will share her knowledge and experience in the stratosphere.
Well, thank you very much. I'd like to thank everyone for attending this conversation, and I hope to get your questions at the end. I will share my screen. I'm holding here a model, obviously, of SOFIA, and there is my jacket, which, by the way, I have next to me. I thought, I'm probably not needing it right now, but I did get to keep the jacket. I'd like you to look at this picture of SOFIA and tell me, or at least think, what's wrong with this picture? And I hope you find it a little disconcerting that there is an open door on a moving airplane. This is in order to keep the telescope, you're looking at the dish of the telescope, cool. This is an infrared observatory, which means that it looks at heat, if you will. You can think about it that way. So hot things like air in an airplane, the airplane itself would be a source. So you're trying to get your instrument as cool as possible. The temperature at 45,000 feet is about 70 degrees below. Now, you're probably wondering, wait a second, I see that 70 degrees below works really well for the telescope, but what about the people on the airplane? Because obviously for us, that doesn't work. There is a wall that separates the instrument from the people, and we'll get to see that again later. And I flattered myself that that wall was to protect us from really cold temperatures, but in fact, no. It was to protect the telescope from our hair and other debris to keep the telescope as clean as possible. Amy already mentioned what SOFIA stands for, but I think it's helpful to look at these words: Stratospheric Observatory for Infrared Astronomy. And we're going to kind of piece that together. Why is this? What does it mean? How did I get to be part of this? I was part of a cohort. A cohort of a total of 24 astronomy ambassadors. And I was chosen, I think, for three reasons. The first reason is that I actually got in my application by the deadline. This might sound obvious, but actually so many of us are working so hard that sometimes getting that thing in on time is tricky. So that was one reason. The other reason was I used to work on an infrared satellite, so I was particularly familiar with the kind of science that they were trying to do with SOFIA. And finally, because I direct now a planetarium, I have a lot of opportunities to do outreach and talk about the program with other people, which of course raises the profile of the observatory. By the way, if you think you've heard of SOFIA lately, you have. It was SOFIA's data that found water on the moon. Why the stratosphere? Why does this telescope have to be higher than the troposphere, the part of the atmosphere that we live and breathe? These are the four areas of the atmosphere for my purposes here. The troposphere is where we live and breathe. The stratosphere is where SOFIA flies. The mesosphere is where most of the shooting stars take place. And the thermosphere is where most of the northern lights take place. To the ground, we only get two kinds of light: visible light, the light that our eyes are sensitive to, and radio waves, and that's it. All other radiation, electromagnetic radiation, all of that outside of those two particular kinds get trapped somewhere in the atmosphere, and that's good. For example, a lot of our UV and our X-rays gets trapped. Those are high energy. It's high energy radiation that would be damaging to us. Infrared is absorbed in the troposphere. So if you get above the troposphere, that's why SOFIA flies above it, it allows us to see infrared sources. The reason why the troposphere is absorbing it is because that's where so much of the atmosphere's water is. And water is a very good absorber of infrared radiation. Okay, so why do we want to observe in infrared? That's an excellent question. Why is this observatory necessary? You're looking here at an image of the Orion constellation. Clearly the blue lines have been photoshopped in. I like to think of Orion as a bow tie, right? Where the two bows connect is where we have the three stars in a row that we call the belt of Orion. When we're looking at Orion in visible light, basically all we see is stars. That's all. We see lots of stars in this part of the sky, but nothing else. Let's see if we were to change our glasses of visible light and put on infrared light, what would we see? The picture is very different. We see a few stars, but that's not the main ingredient here. What we're seeing primarily is gas. We're seeing the clouds that gave birth to the stars that we see. This tells us, this reminds us that in astronomy, it's very common that just one kind of instrument doesn't do the trick. It doesn't give us the whole picture. If we want to understand what's really going on, we need two, sometimes more instruments to see different kinds of light, and then we can put the puzzle together. Now, where you see a really bright spot at the lower half of Orion is where the famous Orion Nebula is. That's probably the most studied star forming region of all. So what was our preparation like? Well, I'll tell you something I think amusing. When I got the phone call to be told that, you know, you were selected to be part of this, and after I danced a little jig in my kitchen, I was told two things. I was told, do not tell us what kind of food sensitivities or allergies you have. This is not a commercial airplane. You will bring your own food. Okay. The second thing they said was that the airplane is going to be loud and it's going to be cold because, as I mentioned before, we're trying to keep everything as cool as possible, and that I should, you know, bring appropriate clothes. The preparation was a week. We got into Southern California a week early. I say we because I traveled with Kathy Gustafson, who at that time was a high school teacher at Nicolet. And we had several sessions that had mostly to do with safety. Now, I don't know about you, but I have been on many, many airplanes. After all, I grew up in Greece, and I go back and visit my parents as often as I can. So I've been on many airplanes. So when the instructor, the safety instructor, was telling us about how to use a flotation device, I said, you mean I can get to pull the red tab I've heard of all my life? And he allowed me to be the test person. So I pulled the tab, and this happens. The idea was that if we had a landing over water, that we could, in fact, float. The other thing we had to concern ourselves with was oxygen, because we find that at 45,000 feet, you still feel gravity. I mean, you're still, it's in many ways, it's just like a commercial airplane, but at 45,000 feet, the oxygen level is considerably lower, which meant that if we lost pressure, we would faint within a few seconds. So we all had a little POS, NASA loves acronyms, a personal oxygen system that we could use immediately. And we would be guaranteed 15 minutes of breathing until we sorted out what the issue was. I see this picture and I have warm, fuzzy feelings, which I realize I have to explain, because for most people, a meeting is not, the highlight of any kind of big adventure. I used to work for NASA, as I mentioned before, on an infrared satellite. And one of the things that I really came to appreciate was that every single day, there would be a meeting of all kind of heads of departments or leads. And the meeting would last for about 20 minutes. Nobody said anything that wasn't absolutely required. And the meeting was very focused on what we needed to know today, for today's uplink. What did we need to know? And it was the very same idea with our pre-flight meeting. We only talked about what were the weather restrictions. Were there any limitations based on the performance of the airplane the day before, anything new? For example, on one of the days that we were flying, there was some issue. There was some small leak somewhere in a door, very small, obviously, but it meant that we could not fly if it was going to rain. Happily, in Southern California, it doesn't rain all that often, so that didn't turn out to be an issue. I really enjoyed how smoothly this meeting ran, with exactly the correct and appropriate information. The program manager on that day was Creighton, the woman on the far right, and I complimented her. I said to her privately, that was a really smooth meeting. And she said, I have plenty of practice. I was for 7 years a high school teacher. And I thought, yep, then you've got that. You've got organizing people really nailed. On the second day that we were flying, because we did 2 10-hour shifts, a videographer was assigned, and he, I guess, was interested in having some kind of heroic footage. So here it is. Our pre-flight instruction, unlike a regular airplane, which involves everybody being in their seats and buckled in, was more informal since we were a smaller group of people. And they were explaining again what we would do in various scenarios, but more importantly, fire. Fire is what takes an airplane from an airplane into a little puddle of molten metal in just a few minutes. So that would be something that we would all help in the very unlikely event that we had a fire on board. I wanted to show you our flight path because it gives me an opportunity to explain a little bit about how that's determined. We left what's now called the Armstrong base. And, well, you'll see for yourself here. You might wonder, what kind of crazy path is that? There are a few things you have to consider to determine the path. And by the way, that is complicated enough that, first of all, there is a first cut at it before we even get on the airplane. But there's also a person on board whose only job it is to make sure that we're following the flight path as advertised, and that any changes that need to be made can be made on the spot. Most airplanes aren't too particular about how we get from point A to point B. There is some, the pilot with the ground crews have some latitude, and they don't really care. But in a situation like this, where the whole path is determined specifically so that we can see all the targets that we're hoping to see, it's very important that we stay within a mile of the original flight path. And that certainly does require somebody keeping the eye on that needle, as it were, and telling the pilot, up, we're off, bring it back to the original plan. So here are some of the things that people have to consider. There are no-fly zones, especially on the western part of the US, and we would try and avoid those if we could entirely. The other consideration is that in the targets that we had, so lots of scientists put in proposals. They want to see these things, I'll call them targets, astronomical objects with SOFIA. And there would be a committee that would decide, based on how good the science is, which of these targets are we actually going to see. Well, they're not going to be visible from any old place. So the point is to put them in sequence so that you can see as many as possible, as efficiently as possible. And the third consideration is that the highest quality data is taken when the airplane is as high as it can fly. Well, it makes sense to do that when you've burned a lot of the weight, a lot of the fuel of the airplane, and therefore you have the highest quality data at the end. All of those things were put in the mix to determine that this was the best flight path that we could have. I mentioned already that we were told it's cold and it's loud. The temperature was not really an issue for us, the Wisconsinites, I mean, because we had escaped from the polar vortex of that year. And to us, coming to California in March was very, very nice. So even though the temperature of the airplane got down to 50 degrees, we were okay. But the Californians, it was sweet. They were wearing, 2 pairs of pants, 2 pairs of boots. They were really, really uncomfortable. You're seeing me wearing a system of communication. I had visions that we would all be shouting at the top of our lungs to be heard, but of course, NASA is better than that. We had opportunities to talk through the system in our regular voices. What was even better was that we could eavesdrop. You could say, oh, I want to hear what the ground is saying to the pilot, or what the telescope operator is saying to the instrument specialist. It was fun. Speaking of whom, there were 26 people on board with various jobs to do. The 2 front people on the left are the telescope operators. The 2 people in the kind of front, but on the left, are computer specialists. And I think the person on the very far left was the person who kept the eye on the flight path compared to where we actually were. And the person on the right was an instrument specialist. Now, what you're looking at is the back of the telescope. So you're seeing some concentric blue lines, and then there's a kind of a cream concentric circle around them. That is the back, that's the wall that I described that separated the telescope from us. And what we're seeing here is some of the equipment that's put on the back of the telescope to telescopes like these aren't, you put your eye at some focal point, you put your instrument there, and you can see a piece of the instrument just next to the person who was responsible for building it and making sure that it's behaving the way you want. SOFIA had two kinds of instruments. It had what you would basically call a camera, things that take pictures, but you would also have spectrographs, which are oftentimes richer ways of getting information about an astronomical object. So you analyze the light that you get in all the colors, even in colors that our eyes can't see but are there in infrared, and help us understand more of the physics, more of the properties of the astronomical object we're looking at. This is a video I'm going to show you, and I'm going to explain it a little bit because it can be confusing, because we're going to see a movie taken with a camera that has been set on the ground. So it's in the same reference as the airplane. And you will have the illusion that the telescope is moving because we're seeing it from the point of view from the same reference as the airplane. However, the telescope is actually locked on to target. So it's fixed. It's saying, I'm looking at this particular source and I'm rock solid. It is the airplane that's moving underneath. Also, I wanted to point out that because the telescope is really heavy, this telescope is, the mirror of the telescope is a little bigger even than the Hubble Space Telescope. By the way, I should explain, there are much bigger telescopes on the ground, right? But these are moving telescopes, which makes it harder to have something as heavy as this. You need a counterbalance, and people realize that there's no point in having dead weight. We might as well use weights that we would need on the airplane anyway. So some of the computer equipment has been tacked on to the backside of the telescope as to double as a counterbalance as well. I'll let this movie rip, and you get to see kind of the activity that's took place over some time, over the, I think, the better part of an hour, maybe more. So you get to see how people move around and do things on the airplane. So we're taking a look at a particular set of data that was coming in. I believe, yeah, I have a screenshot of it. The source, you'll see it in a bit, is called NGC 2264. And what we're seeing here is what looks like little dumbbells, like it looks like we have dots that are connected. The reason for this is that we're looking at a star, right? Now these are in infrared, and everything around that, the air around the telescope, the air in the atmosphere also produces infrared. So we have here both what we would call signal and noise. The way you figure out what the noise is you go off source and you take a picture in what seems to be a dark part of the sky, or as dark as you can make it, and then you subtract the two, and that gives you a better idea of what is actually coming from your source as opposed to what's coming from the air in the airplane, the air around us, the airplane itself, and any other sources of noise. In order to do this well, you have to make this movement several times a second. And because some of these sources are so incredibly bright, you actually see them as the telescope moves from one position to another. As I mentioned, the source was NGC 2264, and this is an image in visible light, where you can see the nebulous. You can see there's, unlike Orion, you can see there's got to be, this isn't just stars, there's some kind of nebulous material here, and nebula is just a Latin term for cloud. We have a larger picture here from Spitzer. This is another space telescope, and took a big picture of this whole region. You might wonder, okay, how does a place be called NGC 2264? Surely we can do better. We can find more poetic names for things. And in fairness, the inner nebula of this, I believe, is called Christmas tree or something like this. But the fact is that there are so many astronomical objects that it isn't practical or even possible to name every single thing that we find. And that would be kind of useless too. The reason why we like these names tells us, this is the new general catalog, and it's the 2264th entry of that catalog. It means that I can go on the internet and find everything that we know about this particular region, and compare it to the literature, what papers have been written, what data is available, all of that good stuff, again, to help us put more information together to understand regions as best we can. Here's another scientist who's explaining the particular project that he was involved in. Most of the projects that were happening while we were on SOFIA had to do with either very young stars or older stars, stars that are producing what we call planetary nebulae. That means that when a star reaches a certain age, it starts becoming a little unstable, and some of the outer layers of it can be released. These layers, because the star has lived a lot of its life already, is enriched with cool things like higher concentrations of carbon, oxygen, nitrogen, the stuff of life. We are particularly curious about these kinds of this chemistry, because that would tell us how likely is it that in these environments around older stars that there could be the ingredients for life. I mean, after all, it is one of the most pervasive questions that we're asking in astronomy today. Are we alone? Could there be life outside of the solar system around a different star? And we're trying to get to the heart of the matter. How would we know what kind of chemistry is required, and all these really interesting questions. I did not expect, to be honest, to spend any time in the cockpit of a 747. And I didn't mention that the SOFIA airplane is a 747, special type S. They stopped mass producing them because they realized that they'd rather have larger airplanes holding more people, even if they're the distance that they could travel was shorter. But this particular kind of Boeing could go for 12 hours on one tank of gas, as it were. In any case, I got to spend a few hours, I think, in the end, in the cockpit of a 747. I've always, as long as I remember myself, I've had bad vision. So I had pretty early on realized that I'm never going to become a pilot. And I kind of thought, well, sour grapes, who wants to do that anyway? I have to admit that the thrill of being behind a pilot for several hours, including the time that it took us to land, made me think that, wow, it would be great to be a pilot. Too bad that that's not going to be one of the careers that I will pursue, but I can see the joy of it. We tried pretty hard to have conversations with many of the crew members to figure out how did they get to be in the position that they are. So I had the great opportunity to speak with Daryl, who was the flight engineer. Now, in in today's airplanes, there wouldn't be a position like this. There wouldn't be a flight engineer, because basically all the instruments that you see here would be replaced, and the person would be replaced by a fancy chip. However, because the SOFIA space airplane had to be changed so significantly to accommodate the telescope, remember, it's trying to fly with one door open, that they didn't want, it wasn't worth the significant expense to change anything with it. So they left it. So there is a flight engineer who flies. And we had a long conversation. He was telling me about how he got to be involved in how he got to be a pilot for NASA. He told me that he was, his grandfather was a pilot during the Second World War. And when Daryl was a little boy, they would go together to the airport and watch the airplanes fly, take off, and land. And his grandpa was telling him about his experience of flying into Sicily during the orange blossom season. Now, I really get that. I really understand the magic of that time of year when the oranges are blossoming. The aroma that they make is something amazing, breathtaking, truly inspiring. So imagine Daryl's delight. Eventually, he went to the Army and became a pilot. Imagine his delight when he got to land back in Italy during the orange blossom season and feel that he's connecting again many years later with his grandfather. So we're sharing all these cool stories. And I said to him, I'm getting a little nervous whether I'm distracting you. Should you be looking at these instruments? And he said, if there is a problem on this airplane, this whole deck is going to light up like a Christmas tree. Don't worry. We'll know if there's a problem. I found it interesting that one of the things he monitored closely was the gas consumption, the fuel consumption on the four engines of the airplane. If they're burning fuel at the same rate, that is good. If not, then that's something worth investigating. It turns out that, of course, everything worked as hoped. Another wonderful surprise, this truly was a gift to us, was that we got to see Northern Lights. I was behind, on the second night, I was behind the pilot, and he said to me, I think there's Northern Lights ahead. And he knew what he was looking at. He knew what he was looking for. And eventually, it's true, we got to see Northern Lights. So I got super excited about that because I had seen Northern Lights in limited ways. I had seen them before, at least twice, but in a limited way. So I get out my phone, I put it up against the window, and I take a picture, and that's what I get. I'm very discouraged because there's nothing. Absolutely, my phone has absolutely nothing. And I'm thinking, how could it be so gorgeous, so beautiful, and my phone catches nothing of it? The pilot shows me his night light goggles, and he said, you put that against the window, you put your phone against that, and you should be able to get a better view. So this is my image with night goggles. I'm going to help guide your eye because I realize even this picture is not so great. Let's start with the brightest point. So this is where we had most light. Remember that the airplane, the ground is emitting infrared light, right? So it's our signal, if you will, is fighting all this other stuff. But let me hopefully guide your eye. This is the edge of the Northern Lights. And you could say, boy, this picture really sucks, Jean. And it's true. This is the worst picture that I'll show you. But it is mine, and I did take it from the stratosphere. A better picture that I took from the internet, but really captures what we saw, was this. It really, really looked like this. It was gorgeous. And I think we were treated to such a wonderful view of the Northern Lights because if you remember, our flight path took us really far north into Canada, northern Saskatchewan, and British Columbia. So it gave us this super duper view of the Northern Lights, also known as aurora. I pulled the shortest stick of the four, which meant that I got to fly. I was in the cockpit on the second flight on the way down. So I was the last person who got to go in the cockpit. But frankly, I think in the end, that was a bonus because that meant that I got to see the Northern Lights that I just showed you and that I got to land in a 747. I got to see the runway as we were coming down, which was pretty thrilling in and of itself. When we landed, I thought it was auspicious that both the moon and Venus were visible. And that was a really nice kind of way of wrapping up this extremely exciting project. And with that, I will welcome you to ask questions. And again, I'd like to thank you very much for your attention and for your presence. I can probably stop sharing. I'll be happy to answer questions that you might have.
Okay, Dr. Creighton, we have an audience question here. How often are trips like this one with SOFIA performed at NASA?
Several times a year. I think I'm trying to remember, I think the goal is 80 a year.
Wow, okay. And what did you find to be the most interesting or unexpected part of the experience for you?
I think I'm going to answer this honestly, and hopefully that that resonates with the person who's asking the question. I mentioned that I had worked for NASA before, and one of my worries in the back of my head, one of the things I was a little worried about was, what if I go to SOFIA and I feel sorry? I feel sad that I left a career, working on infrared satellites and things like SOFIA and Spitzer, and came to Milwaukee and started a whole new career path, whether that would be sad. And I was so relieved, so happy that I feel that what I do now is as important, if not more so, for NASA. NASA needs ambassadors. NASA needs people who talk about the work that we do. And it made me feel really good that I am where I need to be. And I wasn't sure when I started. So for me personally, that was kind of the sweetest part of this experience.
I think that word is perfect for you. You're such an exceptional ambassador on so many levels. So I echo that. You're a jewel in our campus.
Thank you.
So again, we have another. Do you plan to apply for another trip with NASA?
I feel it's a bit piggy. They do try and open it up to multiple educators. So if you are an educator, you could apply for this opportunity. I feel that NASA knows that they probably got out of me all that they could, and I will continue to be an ambassador for NASA and SOFIA. But I think they also, if they were to have a repeat person, it would be likely somebody from California that reduces the cost. I mean, we all have to be practical. It's easier for somebody who's there and you don't have to fly them in and out and have them repeat the training.
Makes sense. And can you tell us a little more about your past positions with NASA?
I was what we call a postdoctoral scholar. So I worked at IPAC, which stands for Infrared Processing and Analysis Center. This was after I finished my PhD. I worked on a satellite called WIRE, which was an infrared satellite, a proof of concept. Can we make a moving observatory? So before SOFIA obviously flew, and before Spitzer, it was a way of determining, can we do this? And it was a fairly small project, I think, for NASA kind of levels. I think the total funding was 80 million, which is a fairly small project. And I was what we call I was the liaison between the main project and 12 science groups. And I was trying to advocate for the science needs of the 12 groups with the principal investigators of the project. But I was also trying to tell the associate investigators, look, these are the kind of parameters we have to work with. So let's see how we can modify your project to fit the hard and fast parameters of the project. And the hope was that if the project went well, if WIRE worked as advertised, then I would join one of the groups as part of their science, and I would be doing that. Sadly, we had a power surge. So although the launch went beautifully and WIRE got at the right height, there was a power surge, and the little cover that was covering this super cooled sensitive infrared instrument got released into space. So the sun fried the instrument. And that meant that within a few hours of launch, we knew that the project, the way it was envisioned, was over. You don't know this, but the fact is that this happens not so infrequently, and JPL has a whole kind of book of what happens when a project comes to an abrupt end. And obviously people aren't tossed out on the street. People have, mortgages to pay and bills to deal with. Life happens. So there is a period of time where there are transfer funds. So it helps people get to a new project. And that's when I thought, should I stay on California and go on to another project? Or should I come to Wisconsin? My husband was already here, and start a family and, start teaching astronomy here. And I decided, you know what? You can't start a family if we're living in different states. So I came here. And as I said, that comes back to what I have regretted that. And I do not regret that choice. I really love what I do. And we have two wonderful young men as a result of this decision. So it worked out very nicely.
Excellent. And do you have any research projects that SOFIA provides data for?
I do not at this time. I am, in fact, in the middle of applying for a grant, for some grant money from NSF. That's the National Science Foundation. It is in the particular field of NSF of advancing informal science. Well, it's actually, it's technically the title is Advancing Informal STEM Learning is what it is. And I'm now in a wonderful collaboration that will bring together ways of knowing both Indigenous and non-Indigenous of how we understand the sky. We're going to tie that in with language, with 3 hopefully nations in Wisconsin. So this is the project that we're kind of working on. We're putting in a proposal right now. I'm very excited to make these connections and learn how best to imagine ourselves embedded in this cosmos, not just observing it, but protecting it as well.
I think that may have answered one of our final questions, but you might want to expound on it a little bit. Can you tell us about some of the other work you're doing in Milwaukee right now?
Yes, I just submitted, and I'm extremely proud of this, given I really had to work hard for this. I just submitted on last Friday a paper based on a project that I have with theater called Tale of Scale. This was a class that we taught on how to use storytelling techniques. Robin Mello is my collaborator. Uh, we um, we wanted to figure out how to use storytelling techniques to explain the scale of the universe. We collected the data, and when the pandemic started, I thought, how am I going to make this time about something positive? How can I say that, yeah, we had a pandemic, that sucked. There are lots of things that really didn't work for me, but how did I do something good? So I said, this is it. This is the time to analyze the data, write up the paper. So I did. I submitted it to the Planetarium, as I said, last Friday. Yes.
Congratulations.
Thank you.
Sounds like an incredible cross-disciplinary project.
I'm really excited about cross-disciplinary projects. I really find that they're juicy in ways that, um, things that you just do on your own are um, not quite as exciting.
Mhm. And UWM faculty have a particular flair in that area. So it's
Mhm.
exciting to see what's coming out. So Dr. Gina, I want to thank you so much. You've been an incredible ally of the Alumni Association. For viewers that maybe haven't had the pleasure yet and have kids and grandkids at home, you had hosted for us 9 different future Panther Academy chats, which are geared toward a younger audience and really opened up the world of the cosmos to our future Panthers. We had over 1,300 folks view those, and they also included really cool at-home activities. So they're still available on demand now. So I encourage anyone listening with kiddos or grandkids to entertain in the near future. They're a treat. They're all available on our alumni website, and we can send a link out and wrap up to this chat as well. So thank you so much. You do incredible work for our community, for UWM, and it's always a treat to feature you.
Thank you. I would like to say I'll put in a shameless plug for the planetarium. We do have a program that started last Friday called Under African Skies. We have 5 people who are affiliated with the university, either as faculty, students, or alums, who are talking about their country. And as I said, we have 5 separate countries. This week, we have a professor in nursing talk about her country of Malawi. And on the December 18th, we have a program on Northern Lights. All of that information, of course, can be found on our website, uwm.edu/planetarium. And I hope you can join us for more programs. Thank you
Excellent.
so much again.
Yeah, we'll make sure to make those available to our audience as well. Thank you so much.
Thank you.
All right, have a great day. Thanks, everybody.